how first was initially it is highly experienced person, and after that young blood. We are having a next speaker who is youngest of all speakers who are speaking in this training program. Engineer Anish Gorantiwar, who is doing his uh, research in US, and currently he is pursuing his research from at Center for Tire Research. It is at Blacksburg, Virginia in USA, and I know him personally. He is an Indian person who is belong to this state and our city only, and we are related to most of us maybe knowing him. But as a mechanical engineer, he has done his BE and from MIT Pune, and now he has gone for his MS, and continuously he is pursuing as a graduate teaching assistant now in this Center for Tire Research, and working on algorithms for uh, image processing. So this lecture will be helpful for those who want to pursue their career in next few days. Most of the students would like to have this as their new career. So I welcome Anish, and I hope he has joined and he's there. Great.
Yeah,
So welcome Anish, and oh,
yeah, I'm here.
copying your father. So, it's like Abdul, best of luck for your lecture, and I hope participant will feel it. This will be energizing lecture. So Anish, please.
Yeah. So first of all, hello everyone. Can you hear me?
Yes, yes, yes.
Yes. So first of all, I'd like to thank everyone for giving me this opportunity and especially this platform to talk about some portions of my research. And I believe that after having this conference, after having this talk, most of the students and most of the people, mostly of my age, will basically benefit from this talk, and they'll at least have some kind of idea in while they go in this unmanned aerial vehicle domain. I think I'll just share my screen now. So can you see my screen?
Yes.
Okay, yes.
Yeah,
So
it is.
okay, thank you. So just to give a short introduction about myself, my name is Anish Gorantiwar, and I'm a graduate researcher in the Center for Tires Research Lab at Virginia Tech. So most of the projects which happen in our lab are basically dependent upon different intelligent tire technologies and mostly on tire wear or friction. But we've started a new kind of project phase which deals with unmanned aerial vehicles as well as unmanned ground vehicles. So for today's talk, I would like to give a brief introduction about the hardware and the software related to the unmanned aerial vehicles and just touch up on some very small and simple algorithms so that everyone can at least get started in this research. So before diving much into detail, I just like to give a brief outline of all the topics which we might cover today. So initially, I want to talk about, give a brief introduction about the unmanned aerial vehicles or the drones as it's commonly called. Then I'll overview through different types of UAVs which are commercially present in the market. Then we can basically go to the system architecture. So what I mean by system architecture is we can basically explain all the hardware and the software components which are present in your drone. And then I'll move on to explain different types of hardware, different types of softwares, and how they eventually combine with each other. So what exactly is an UAV? We've heard this term UAV a lot, but many people don't have, even me, I didn't have much knowledge about this UAV field when I first entered it. So UAV essentially stands for an unmanned aerial vehicle, or drone as it's commercially called. And it's basically an aircraft which does not have a human pilot on board. So the UAV can either maneuver autonomously or it can be remote controlled by a person who's on the ground. So just to give a small introduction about my research. So I currently work on a collaboration between an unmanned aerial vehicle, which you can see on the top, and an unmanned ground vehicle. And most of my projects are related to combining both of these things for different applications. Okay, so now again, the drones are basically used in wide number of applications. So to start off with, one of the most important and a critical application is the agricultural domain and remote sensing. So the UAVs in agricultural domain are typically used for two applications. One can be basically pesticide or your chemical spraying, and the second one is generally remote sensing. So remote sensing includes basically sensing vegetation and studying different properties of vegetation. The second important application is security as well as emergency responses. So a very critical example in this, which I can give is, for example, whenever there are wildfires which occur, so it's very difficult for humans as such to traverse the entire jungle, the entire forest, and to see where the fire originated or how it's spreading. So this is where the unmanned aerial vehicles and the drones come into the picture. Because of drones, since they have a very high speed and they have good enough flight time, especially the new researched ones, so we can cover large distances in a small period of time. The third application is essentially weather forecasting. Again, this is also a critical application when it comes to in terms of studying different weather patterns, especially wind patterns which occur in a specific region. So during in those regions, similar drones can be basically used. And the last but not the least application is basically surveying and mapping. So this is useful when it comes to surveying a particular perimeter or gaining some kind of information about a particular environment or a particular surrounding. And we can take aerial images and see what exactly is going on. So Google Earth, for example, is basically a very critical application of surveying and mapping of UAVs. So I'd just like to give a brief introduction to the different types of the unmanned aerial vehicles or the drones which are commercially available in the market. So we'll essentially go from left to right on the screen. So the first one is basically a fixed wing UAV. So as you can see from the image, the fixed wing is essentially similar to an aeroplane, a normal aeroplane. So its major advantages is, since an aeroplane, it can cover large amount of distances in a very small period of time. But one disadvantage of it is it cannot hover at a particular position. That is, it cannot stay at a particular position for a large period of time. That is why these fixed wing UAVs are not commonly used in some of the applications which I mentioned above. So the next one, and probably the most commonly used, are the multi-rotor UAVs. So the multi-rotor UAVs have a very important advantage that it can basically hover at any particular position. So it can take different aerial imagery and collect data at different points. The next one is a single rotor. So it's basically a subset of your multi-rotor in the sense that single rotor only consists of a single propeller, which moves on an axle. So a helicopter is a very common example of a single rotor. Now, even though the helicopter can also hover, but it's a big downside, or you can say a big limitation of this system is it has a higher complexity in actually moving the helicopter around as compared to the multi-rotors. And the last one, which is currently gaining a lot of importance in the research fields of the UAVs and drones, is a hybrid vertical takeoff landing system. So when I say a hybrid UAV, what does it mean? So hybrid UAV essentially takes out all the advantages of the fixed wing and the multi-rotor, and it combines them together. So this is a very important advantage in terms that the drone can basically fly, as well as it can basically hover at a particular position, as well as it can move forward as well. Okay, so now before diving deep into what exactly a UAV is and what are the different components which are present in a UAV, I would like to give a brief introduction, not an introduction, or basically I want to give a brief application of what are the different subsystems which are present in a UAV. So we can essentially divide the entire UAV into two parts. One is your software system, the software stack, and the second one is your hardware stack. So the hardware consists of all of the different components which are mounted on the UAV. So it might be a camera, a motor, a battery, and basically we'll discuss about each one of these components in detail. But this is what the hardware stack consists of. Then it consists of how can we communicate between one component and another component. And finally, whatever the software algorithms which we do, how do we deploy them on the hardware? And the second subsystem is basically the software stack. So the software stack essentially consists of, again, the different software algorithms. For example, image processing. So if I take an image, what all data can I take from that image? So say I have an image of a vehicle, a building, and a car. So I should be able to identify that this is a building, this is a vehicle, and this is a car. So that is where the perception or the image processing comes into the picture. The second stage is a motion planning. So what motion planning says, you say, for example, I want to go from one point to another point. So as humans, we know how to go through that point because we have our visual perception. That is, we have eyes and we know where the obstacles are. But for a UAV, that is very difficult when it comes to autonomous flying. So that is where the motion planning and the controls come into the picture. So initially, I'd like to give a brief introduction about the hardware structure. So this is just a conceptual design of a UAV to just give all of you an idea of what are the different components which are present and how each and every component communicates with each other. So we'll just start on discussing each one of these components. So the first and the very most important component of the UAV is essentially a flight controller. So the flight controller, you can say, is basically the heart of the UAV. So what the flight controller does, it will take in different inputs from the sensors and it will basically run all the motors which are present on the UAV. The second is a power distribution board. So since we have a battery which is present on the UAV, the power distribution board will help us to route the power from the battery to all the four motors in this case. Then we have the motors. We have the electronic speed controllers, which I'll discuss more in depth and detail. Then we have our propellers, which are essentially used for generating the thrust from the motors. Then we have a GPS, which is a global positioning system. So the GPS basically allows the user to know the position of the UAV in the world coordinate frame, where exactly the UAV is located. So next is a high-level controller. So generally, high-level controllers, you won't see many high-level controllers in commercial drones, but when it comes to research project drones, especially in the fields of agriculture or weather forecasting, high-level controllers are basically used to do different types of software algorithms. So then we have the frame, which forms the base structure, and then we have the battery. So I'll just give a very, very small introduction about each one of these components. So frame, as you know, it basically forms the base structure upon which all the individual components are built. So there are conventionally two types of frames which are available. One you can see is the commercial frames, which can be directly bought from the market. And the second one is a custom frame. So the custom frames generally are dependent upon the user. So say, for example, I'm designing my UAV for pesticide spraying. So for that, I would need to make sure that my drone has sufficient amount of space to say mount my nozzle, to mount the pump and to mount my pesticide container tank. So that is where the custom frame comes into the picture. Yeah. Now next is the motor propeller. So motor propellers are essentially the main thrust generators of the body of the UAV. So there are a variety of motors available, but the most commonly used are the brushless DC motors, or they're called as the BLDC motors. The main advantage of using the BLDC motors is that they have a very high energy density. That is, for a given amount of current, they can generate a large amount of thrust, and so the UAV can attain a very high acceleration and it can move high up from the ground. So just to give a small keynote here, while selecting a motor, one important parameter to be looked upon is how much thrust the motor can generate, corresponding to how much current it takes from the battery. So as you can see from the graph on the right, as the current drawn increases, the thrust also increases. But the UAV is essentially a cyclic process. You cannot have too much thrust because you'll need a larger battery, and hence the weight of the UAV will increase, and again you'll need different motors. So it's essentially a cyclic process, and we have to start at some point. Okay, so next is the electronic speed controller. Now, in order for the motors to have different speeds so that the motors can move left, right, forward, backward, up and down, it is very necessary that the user can basically control the speed of the motor. So this is where the electronic speed controllers come into the picture. Yeah, the next is the battery. So the battery basically forms the powerhouse of the entire UAV. So commonly LiPo or the lithium polymer batteries are used because they have a very high energy density. So when I say it has a high energy density, it basically means that it can continuously supply sufficient power for a longer period of time. And so important points to be considered while selecting a battery is not only the voltage which it has, but and not only the number of cells which it has, but along with that, we basically need to kind of prepare a model. So for example, if I use my battery for say 5 sensors, then how much time would the battery last? So this is a very important and a critical thing when it comes to UAV design. So if you can see the model on the right, that's a basic simulation model, a software algorithm which I created on MATLAB. And it basically helps the user to know, say, for example, if you're using 10 sensors, then your battery will last 10 minutes. If you're using 15 sensors, then the battery will last only for 5 minutes, and so on. Now, the next and most important thing is the flight controller. So as we discussed before, the flight controller essentially forms the heart of the entire UAV. So all the different sensors are connected to the flight controller, and the flight controller tries to manage the UAV. It tries to make the drone fly stable. So you can see it has its own software. So if you can see in the middle figure, you can see 3 green dots which are connected by 3 yellow lines. So those are basically the coordinates where we want our drone to fly. So we just have to select on those coordinates and the drone will fly accordingly. And there was a short animation on the right. So we need to calibrate all the sensors which are connected to a drone so that all of these calibration can be done by the software itself. So this software is essentially called a mission planner software. Now, I gave a brief introduction about high-level controllers. So a common high-level controller is a microcontroller called Raspberry Pi. So what this does is it collects all the data from the flight controller, and all the software algorithms such as the image processing or the motion planning are implemented on this high-level controller. So say you want to drive the UAV autonomously. So for driving the UAV autonomously, we definitely need a high-level controller. So we've talked about all the individual components, but I just wanted to give you a basic flow diagram about how these individual components are connected to each other to form the entire UAV. So as you can see from the figure on the left, for a quadcopter, that is a drone which has 4 motors. We have 4 different motors. We have 4 electronic speed controllers, which are given by ESC. Then we have a flight controller in the middle, a battery, and a power distribution board. And then we also have a transmitter and a receiver for the user who's on the ground and who's controlling the drone. So these are just some of the flight tests videos which I would like to show. So these test videos are conducted in our lab. And one important thing to notice in these videos is it's not always easy to fly a drone autonomously. There are very small critical constraints which many people miss out on. So as you can see in this videos, I hope the videos are clear, but as you can see in the videos, the drone is flying autonomously and it kind of remains steady for some time, but afterward it just loses its track. So because of this, we essentially need to tune a lot of parameters. So now I would like to give so this was the hardware stack, and now I would like to give a brief introduction about the software stack. So, and before moving to the software stack, how does the drone actually move? So just to give a small analogy, we know that, for example, if I'm driving a car, I know I can steer left, I know I can steer right, I can accelerate and I can brake. But for a UAV, it's in your 3-dimensional space. So you should have another motion. So for UAV, there are 3 different kinds of motion. You have a yaw, roll, and pitch. So I'll start from the figure on the left, which is yaw. So this yaw is essentially equivalent to a driver which is steering the car. So I steer left and right. It's the same principle as yawing left and right. The second figure is on the right is basically rolling.
Excuse me, Anish.
Yes, yes.
Your screen has stopped and it is not. Your first slide is only visible to all of us.
Oh, only the first slide.
Yeah.
Okay. I think I'll just share my screen again. Okay, so which slide can you see now?
Battery.
Okay,
Battery.
battery. Yeah. So were you able to see all the previous slides?
Yes, sir. Yes, sir.
Okay, thank
No
you.
problem.
Okay. So as I was saying, I'll just move a bit ahead. Yeah, as I was saying, the aerial dynamics. So we discussed about yaw, then there's roll. So for example, if my hand is the UAV, then roll is basically I'm going towards left and right, left and right. And similarly, we have pitch in which I go front and back, front and back. So these are 3 important dynamics which are related to a drone. So we talked about all the hardware, but we missed upon important point, which are sensors. So there are different kind of sensors which can be connected to the drones. So just to classify, these sensors can be broadly grouped into 2 different components. One is your proprioceptive sensors, and the second one is your exterioceptive sensors. Now, these are especially heavy and broad terms, but they have a very simple meaning. So when I say a proprioceptive sensor, it basically indicates sensors which gather information about the UAV itself. So just to give a small example of this, for example, nowadays we see many people wearing Fitbits so they can measure how many calories they burn or what their heart rate is. So that is a very good example of a proprioceptive sensor because it gives information about the bodies itself. So in our case, the proprioceptive sensor gives information about the UAV. The second category is our exterioceptive sensors. So these sensors essentially give us information about the surrounding conditions. And a very good example is a camera. You know, a camera will give you information what is to the front of the drone, left, right, and so on. And there are different kind of sensors. There is camera, LiDAR, and radar. So I would just like to give a much detailed introduction about three important sensors which are commonly used. So first is camera, LiDAR, and an IMU. So cameras, as we all know, they're basically analogous to our eyes. So cameras are used for visual perception. We can correct different kinds of data, and then we can use different data processing techniques. So as to say, this is a tree, or to say this is a building. That is what all the image processing can be done. The second is your LiDAR, which stands for light detection and ranging. So what LiDAR does is it helps to measure the distance between the UAV and an obstacle in front of it. So to just give a brief idea about how a LiDAR works, so it basically sends light pulses, and then once the light pulses reflect from an obstacle, it comes back to the LiDAR. Then it calculates the time required for the reflected transmitted pulse to come back, and then it calculates the distance. So that is a very simple working principle of a LiDAR. Now, the third and the most important sensor is your IMU. So an IMU stands for an inertial measurement unit, and it is a type of a proprioceptive sensor. So as discussed before, a proprioceptive sensor will give information about the UAV itself. So drone itself. So this IMU will give us information about what is the velocity of the drone or what is the acceleration of the drone and so on. So these are the three most commonly used sensors. Okay, so finally we can dive into image processing. Now we know what all kind of sensors are used for image processing. So I'd like to give a brief introduction about the different techniques which are present in image processing. So we won't be covering all these techniques today, but I'd like to give an introduction to two of those important techniques, which is called as a segmentation and an NDVI imaging. So as you can see from the figures on the right, for example, say you have an edge detection. So you have an original image on the left, and when I apply edge detection algorithms, I can only find this round edge, the edges of the entire UAV. So this is very important when it comes to identifying a tree or a building. I don't have to identify the entire structure, just the outline is also sufficient. Similar examples are a feature detection algorithm. So a feature, and a very common example of a feature detection is, say, for example, I take a picture of a building and then say that building has 10 different windows. So this feature detection algorithm will help me in identifying those different windows. So that is what and these are just very few of like nearly n number of techniques which the image processing has. So before diving into different processing algorithms, there is a very important step which comes into the picture, which is camera calibration. So say I purchase a camera directly from the market. I cannot use this camera as it is. It has to be calibrated. So when I say why do we need to calibrate the camera? So essentially there are some kind of errors which are present in the camera and they are called as distortions. So say with the camera, I take a photo of a straight line. But if the camera is not calibrated, I'll see that straight line as a curved line, which is a very big disadvantage. So that is why we need to calibrate the camera. So we'll start off with one important image processing algorithm, which is called as your NDVI imaging. And this is very, very commonly used and highly used in all of the agricultural applications, especially in remote sensing for the drones. So what NDVI stands for is normalized difference vegetation index. And it basically is a parameter to see if a particular crop is healthy or it's unhealthy or if it's basically damaged. So the basic working principle is you can see there's a formula below, and I'll just try to explain in words what that formula essentially indicates. So the formula says that the NDVI is equal to NIR, which stands for near infrared light, minus R, which is basically the red visible spectrum, upon NIR plus R. So to explain in words what this formula is, if you can see the figure on the right, say for example, the left one is a healthy crop and the right one is an unhealthy crop. So whenever light falls on a healthy crop, the infrared light basically falls on the healthy crop. It reflects most of its light. Whereas when visible light falls on it, it doesn't reflect that much amount of light. So using NDVI, we can tell if a crop is healthy or unhealthy. Yeah, so this is just to give a brief idea about how the NDVI values vary with each other. So they can grow from -1 to +1, and say we got an NDVI value of -1. So it indicates the crop is completely unhealthy and it's completely dead, or it's basically an obstacle or a normal object. Whereas if we have an NDVI value of 1, then that indicates that the crop or the entire vegetation is very, very healthy. So, okay, so this was just simple image processing algorithms which I was able to do. So the figure on the right, as you can see, that's a normal image, a red, green, blue, or an RGB image as it's called. And the figure on the right is basically your NDVI image. So as you can see from the figure on the left, wherever there are green patches, we basically get correspondingly yellow patches on the NDVI image. And as we go from blue to yellow on the NDVI, the value of NDVI goes on increasing. So we know that the yellow ones have a vegetation, whereas the right ones have either dead crops or they have no crops at all in that region. So this is very important when it comes to application of drones in remote sensing and in the agricultural domain. So one more image processing technique, and that is also commonly used, is called as a semantic segmentation. Again, this is a very heavy word and a lot of research is going on, but I'll just like to give a small introduction to basically explain what semantic segmentation is. So if you can see the figure on the left, the entire road is painted in blue, the car is in green, and the buildings are in red. And you can see the pavement or the sidewalk that is in yellow. So what we can do with semantic segmentation is I can group all the objects which are present in an image into different groups. So I can give group number 1 to roads, for example, group number 2 to buildings, and then it will color all of these individual groups in a single color. So this makes my image processing tasks very easy because I know whatever is in red is a building, or say whatever is a green is in car. So this is very important when I need to maneuver the drone from one point to another point. Okay, so we talked about image processing, basically the perception system. Now I would like to give a small introduction about the control subsystem. Now, I like to give a small analogy which will help you in understanding what control subsystem is. So say, for example, I'm driving a car and I want to take a left turn. And say you're at some high speed, say you're at 40 or 50 kilometers per hour. So I cannot generally directly take a left turn. I'll make sure I'll take a small left turn, then I'll correct it again, take a small and correct it again. So this corrective action which I do, that is the responsibility of the control system. So we know that UAV has 3 motions, that is roll, pitch, and yaw. So your control subsystem helps in managing these 3 motions. So hopefully, I think the video is visible. So you can see this is a small animation which I was able to do in MATLAB. So it basically indicates how well I'm able to control the UAV's different motions. You can see it moves to the left, moves to the right, and then it comes down. So this is what control basically does. I can tell it to go left and right, and it will try to match whatever input I give it. Okay. Now the next subsystem is a motion planning subsystem. So again, I discussed a very little about this and before. So say I want to go from point A to point B, and say I'm driving a car. So mostly as human drivers, we know how to go from A to B. Either we have the routes memorized or we have a GPS system, and we can drive the car. We know if there's a car coming ahead, we can basically avoid that car and keep on moving on the road. But that is not the case for autonomous drones. We have to design specific algorithms so that the drone can move from point A and further it can basically go to point B. So this is where the path planning and the trajectory generation algorithms come into the picture. So I would just like to just show a brief videos about how the path planning works. I hope the video is visible. So as you can see, the obstacle objects in the green represent obstacles, and the UAV was essentially able to maneuver through these obstacles and reach an open position. So this is one kind of path planning. So the UAV was able to detect where the obstacles are, and it planned its path accordingly. So the next is the trajectory generation. So the difference between path planning and the trajectory generation is the path planning will tell me how to go from point A to point B, but the trajectory generation, that will tell me with how much velocity or how much speed I should go from point A to point B. So as you can see, the shape in blue, which is basically a shape which corresponds to a number 8, that indicates the desired trajectory which I wanted. So as you can see, both the UAVs were not able to get that trajectory in the first step, but as it went on about and about on that same trajectory, it was able to achieve that goal, and it was able to achieve that trajectory. And again, one more example of the trajectory generation is basically, again, following the spiral path. So this is very important when it comes to the agricultural domain, especially pesticide spraying. So see, I have a very big farm or a small farm, and I want to spray pesticides over the entire farm. So what I can do is I can give already a predefined path. So say it's a spiral path, as you can see in the figure on the right, a nearly a spiral path. And I can make the UAV go on that spiral path, and it can basically keep on spraying pesticides. So that is a very common example of a trajectory generation. You can see most of these algorithms are very, very easy to implement. And once these algorithms are implemented on the software through the flight controller and the high level controller, we can easily implement them on the hardware also. So I'd just like to give, I didn't discuss much about the application of UAVs in the agricultural domain. So as you can see, this is a very small simulation which I was able to do on a software. So it basically indicates the flow pattern of the UAV as it moves around. So the figure on the right indicates where the different nozzles are present for the pesticide spraying. And then the animation on the left, that indicates that how my pesticide spraying will basically affect different crops. So in this case, since I wasn't able to simulate crops, these are basically cuboids. And so you can see how the flow pattern is basically distributed over the entire crops. Okay, I think this was a pretty small presentation. So, but just to conclude, we basically went through most of the hardware setup. Then we covered different image processing techniques. I showed you some videos about flight testing, how that works. And then we went through the motion planning. So how to go from point A to point B and how to control the motion of the UAV. And so all in all, these are only, not all, but some of the algorithms which are used in UAV, and only for some kind of applications. But UAV in general is a very, very vast field. And personally, since I'm also a student, I still feel that I'm learning about UAVs. And the more and more you learn, you feel like there's so much more still left to learn. So with that, I'd like to conclude. And again, thank you everyone for giving me an opportunity. So please let me know if you have any questions.
Okay. Thank you very much, sir. Thank you very much, sir, for delivering a very informative lecture on unmanned aerial vehicle based image processing algorithm for classification and segregation. This is very important topic, and your lecture will definitely be more useful to the students, young researchers, and practitioners who have joined this training program.
Okay, thank you so much.
There are some questions in chat box.
Okay, sure.
Okay. We may not able to take all the questions, but with your permission, I would like to take a few questions.
Sure, yes, definitely.
Soumya Das asked, I have one question. Is this technology relevant for Indian agriculture?
Okay, again, this is a very good question. And so based upon the research which I've done it's very difficult to implement such kind of technology when it comes to dealing with small scale farmers, because the cost of the entire subsystem in general is very high. So unless these quantities are mass produced, then only basically we can use these technologies in the Indian farming scenario. But again, they're starting to be implemented, and I firmly believe that within 10 or 15 years, these technologies can be implemented in the Indian farming domain as well.
Okay. Thank you, sir. Then Mr. Balaguru has one question. If heavy wind area, pesticide application is possible through drones?
Okay, yeah, again, so that is also a very good question. So just to answer that question, so whenever say I spray pesticides or I spray chemicals, two important factors which are to be considered, as you suggested, is the surrounding wind and the height at which I'm spraying the UAV. So both these quantities are basically interrelated to each other. So if I'm able to achieve a smaller height for pesticide spraying, I can somewhat negate the effect of wind, and I can basically, as we discussed about the control subsystem, that is where the controller comes into the picture. So say if I design a very good controller, then it will be able to basically negate all of the all of the basically the motions which are caused by the wind. So say the wind is moving my drone to the right. So with the help of my control system, I can make the UAV move to the left. But again, this is again a very critical, a very fine tuning of the parameter of the algorithm is required. But when you have extremely high winds, then pesticide spraying is very difficult. But for smaller wind speeds, it is definitely possible.
Okay, thank you, sir. Then Fritz Cameron has one query. How effective are application of UAV in aquatic plants?
In aquatic plants, okay. So again, this is also a very good question. So when you say aquatic plants, like at least as per my understanding, I believe that aquatic plants are based again. So you'll basically need different types of sensors. So a very important sensor which can partially be used is a sonar. So a sonar is basically sound and ranging. So it's similar to a LiDAR, but sonars are commonly used in submarines. So with the help of sonar, we can basically indicate at least where the plants are located. And then right now research is going on to basically make, I don't know the term for it, but basically research is going on to make UAVs which can fly in the air as well as go sub-water as well. So if you have a sonar mounted on the UAV, hopefully we will be able to detect the aquatic plants, and then the UAV in the air can basically go underwater, and if need be, and then it can see what all different, basically it can collect the data for the aquatic plants as well. Again, this is just as per my understanding. I'm not too familiar about the research in this field in basically aquatic plants, but I believe some kind of system can definitely be built.
Thank you, sir. Then Joseph Cameron from Nigeria has asked, which of the image processing techniques is more used actually in agriculture?
Okay, so in agricultural domain, one of the most important image processing technique is the NDVI imaging, which I suggested before, because NDVI imaging is very important for remote sensing as well as pesticide spraying. So for example, since with the help of NDVI imaging, I can identify whether the crop is healthy or the crop is unhealthy, then I will basically tell my UAV to only spray pesticides where I want the pesticides to be sprayed. For example, if the crop is very, very unhealthy and it's nearly about to die, I won't tell my drone to spray pesticides in that region. So I can set different threshold values corresponding to my NDVI imaging. So this is so the NDVI imaging is basically very important image processing technique which is used for UAVs in the agricultural domain. Along with this, I would also like to add an image processing technique which is basically feature detection. So feature detections are commonly used, for example, in the previous presentation, as we saw, for example, for robots, for ground robots which want to collect fruits or something. So that is where feature detection algorithms come into the picture. So as a user or as a robot in general, I need to identify that whether this is a fruit or whatever that object is. So that is where your feature detection image processing algorithms come into the picture. So these are the two main algorithms which I believe are generally used.
Okay. Then Giridhar Usendi has a question. If sometime occurred any type of diseases in a farm, but don't know farmer know about the diseases occurred or not, that time it is helpful for monitoring the diseases.
Okay, again, so this is also a very, very good question. So I'd like to answer this question by just giving a very little background about how to tackle this question. So this is where machine learning basically comes into the picture. So what machine learning will tell you, say for example, I've already collected the data for 3 diseases which occur in the plant. So I know if disease A occurs in the plant will look like this. If disease B occurs in the plant, it will look like this. And if disease C occurs in the plant, it will look like this when I take its photo with the help of a camera. So if I already know what all the possible diseases which can occur, then by using camera and different image processing techniques, I can identify, if I take a new picture of a camera, then by matching it with all the data which I already have, I can say that this plant has this disease or this plant has this disease. But the main I won't say drawback, or the main limitation of using such an approach is that we need to have a very high data set, very large data set. That is, we need to cover all of the diseases present and corresponding to all of these diseases, how different crops look like. So this is again just one of the approaches to go for this, but I'm pretty sure there must be other approaches as well. But machine learning is one of the approaches.
Okay. And I ask last question.
Sure.
Dr. Shyamrajan Das from ICR New Delhi asked, which UAE is appropriate for precision farming?
Okay. So in basis of for commercially brought UAVs, I believe that there's a company called DJI Phantom. And so, yeah, it's DJI. So DJI has recently started production of UAVs and drones, which are very, very specific to precision agriculture. So the applications which those drones cover basically lie from either, as I said, pesticide spraying or chemical spraying up to remote sensing as well. So these drones are basically the forerunner, if you can say, in the precision agricultural field for the drones. So I'd suggest the DJI, if you can, these drones are commercially available as well. So you can just search for DJI Phantom drones, and those are the most. There are many other drones as well, but these are the most commonly used for precision agriculture.
Okay, thank you very much, sir, for the information of all the participants. There are still few questions and queries in chat box.
Sure.
We shall try to pass on those to the experts and convey you the response of experts through WhatsApp group or email.
Okay, sure, definitely.
Okay, thank you very much, sir. Now I would like to request Dr. Mukund Shinde, sir, organizing secretary of this training program, to propose vote of thanks.
Very nice and introductory lecture on drones, fundamentals of drones. There are more than 800 participants, and I believe most of them are very new to this technology. And we are sure that all of them are very happy and satisfied the way you deliver explain the fundamentals of the drone technology. And it's bit applications for agriculture, precision agriculture. And let us hope to meet you again. And
yes, definitely.
Yeah, congratulate on behalf of MPKV Rauri and the CAST project.
Oh no, so, thank you so much. Thank you.
Very nice lecture.
Okay, thank you, sir.
And all the best wishes. Thank you.
Yes, thank you.